damn, it has been a while since I uploaded something worth watching, but today I feel like recording. I don't know why, but I mean, I did something pretty cool about what I'm talking about today, which is special right angle triangles. Um, so I don't know if my sentence is clear. What I meant to say is today I did something cool about what I'm going to talk about today. So, um, about a year ago, maybe more, I made a script on my iPod that would basically generate numbers. What the fuck? I hate how slow my computer is about like opening this stuff. I just typed something like before I said I hate how slow my computer is. I typed note. And have you seen how long it took for it to just open Notepad? It's absolutely insane. But yeah. Basically what it did is like for A equals, well I guess I could do C equals 1, let's say 100, do, and then for A equals 1, C do, and then for B equals 1, uh, I guess I could say A do, and then it would be um, if C squared minus B squared minus A squared equals 0, then print A and then B, C, like whatever, I'm not gonna do it formally, but yeah, and then it would be like and then that would pop up a bunch of triangles, right? A bunch of right angled triangles. But then most of those you don't care about because the first one that's gonna print is 3, 4, 5, or well, I guess it, no, okay, yeah, it would print 3, 4, 5, and then it would print 13, 12, 5, and then it would print, is it something like 17, 8, 15, yeah, and then it keeps going. Um, but what that script does is instead of printing that, it would also print stuff like this. Oh yeah, I didn't do that properly. I guess I did say ABC, but the way I did it is more like a CAB. I wanted to. Alright, so yeah, let's do 5, 4, 3, and then here let's do it would have printed 10, 8, and 6, because there's no restriction. It would just have done that. It would also have done 15, 12, and 9, and you don't care about that one and that one because they have a common factor, which is 2 for this one. So this is 2 times 5 and then 2 times 4 and then 2 times 3, which is exactly this triangle scaled up. So you don't want that one, you don't want that one. So here I added an if, and that if was like, if you have already done that triangle, like those triples, then don't print it. The way I did it was not very clever, and today I realized there's a better way to do it, but it's still, it takes less space to write it the way I did. But basically it would put an input. Let's say it would do like a to the 3. No, that'd be too complicated. I don't remember what I did. It was like b minus a over c, and then that b minus a over c, if that's already in that like whatever string which contains stuff, if that thing is already in there, then don't print it. But if it's a new one, then print it. And then that removed those ones. And then I realized, hey, I always get, of course, those are always going to be odd numbers. You're not going to get an even number here because then, okay, imagine you get an even number there, right? And it's like 8, and then you would have like, I don't know, like 5 and 5. Well, okay, let's say that would not work. 3 and 7. Okay, that could make sense, right? That's like 49 plus 9, 58. Okay, it might be a bit too high, but let's say 5. That would be 64. That does not make sense. 49. Yeah, that would be 74. There we go. Um, So if you add that up squared, that's 74, and then that one is 64 when you square it. So it doesn't work. But imagine it did. Um, what you would have is something that would be 2x squared equals 2x plus 1, or let's say 2x plus a squared, and then plus 2n plus, well, oh fuck, 2n plus a squared. So this n and this x, for here it would be like x equals 2, a equals 1, and here it would be n equals 3, a equals 1. So what I mean by that is it's really easy to understand why you can't get an even number by adding up an even number squared and an odd number squared. But because you would get like, if you square an even number, you get an even number. If you square an odd number, you get an odd number. That's really easy to understand. So now, if you add an even and an odd number, you're not going to get an even number. So that's not a possibility. So this a and this a are the same. So imagine if a is equal to 0 in this case, you'd have 2 times something, and then here you'd have 2 times something plus 0, and here you'd have 2 times something plus 0. And that's what I said I didn't want. There's a common factor here. If it prints all the ones that have common factors, we're never gonna fucking end this. Although there is a proof that there's an infinite number of different right angle triangles, but I'll talk about that later. So now we have to say it's plus 1, and then if it's plus 1, then that means you have 4x squared equals, oh yeah, I shouldn't have put x here, I should have put like c. Don't get confused with this c or like that c, which are the same there, but not here. And then that would be 4 times, well, 4c squared plus 4c plus 1 plus 4n squared plus 4n plus 1, and that gives you 4 something equals 4 something plus 2. So you can't add up two odd numbers squared and get an even number squared. So that is not a possibility. So that's why these are only odd numbers. So now that we got that out of the way, I optimized my script a bit to see if instead of looking for c equals that, I did like here 2c and here I did 2a, and I said if 2 times c plus 1 squared minus that equals 0, then that, and then I realized, well, one of these is going to be odd and one of these is going to be even, so I can do this and then remove that. And yeah, that was wrong just a second ago, but whatever. And then I realized also, well, while we're here, we can do a equals 2 times a plus 1. And then here you just remove that. Yeah, I didn't do that in the right order, did I? Whatever. I'm not doing this properly at all right now, but trust me, this is somewhat going somewhere. So, you're always going to get an odd number, even number, odd number. And I started noticing a pattern when I looked at this. I didn't know what to do about a week ago. I started trying to optimize my script a bit, and I realized that this number, the even number in the middle here, is always a multiple of 4. And that's a bit weird because, I mean, why is it always a multiple of 4? Why can't you have, 6? Why can't you find a triangle with 6? And I haven't thought about that too much, but I also realized that this number, the hypotenuse, is always a multiple of 4 plus 1. And I also realized that there's a slight correlation between what this number is and what these two numbers are. So you always have a multiple of 4 plus 1, multiple of 4, and then multiple of 2 plus 1. So it's either a multiple of 4 plus 1 or plus 3. You can't really tell. So what I did is I looked at their modulo 8 instead of 4, and I realized that it would always be something like this. Um, it would always be something like this. So the modulo 8 of the first one, since it's a multiple of 4 plus 1, it's always either a 1 or a 5. The second one is a multiple of 4, so it's either a 0 or a 4. But you never get a 1 and a 5 or a 1 and a 3, and you never get a 5 and a 1 and a 5 and a 7. You always get these like paired. If it's a 5, it's a 5 or a 3. If it's a 1, it's a 1 or a 7. So then I changed my script to even better, because here I changed these to 4 when I figured out they were always multiples of 4. And then today I optimized it to say, hey, it's a multiple of 8, and try to add 1 to it, or like to add 1 to the last one or remove 1 to the last one if it's a multiple of 8 plus 1. But if it's a multiple of 8 plus 5, then try to add 5 or remove 5, or add 5 or add 3. And that made it even faster. And now I'm able to find all the possibilities for special right angle triangles, which are these. These are the first few examples. Um, Let me find, is it 16 or 17? 1 second. Less than 256. Damn, that did not work, did it? It might be 17. 1 second. I thought there was a line on this wiki page that said there's either 16 or 17. I guess I can count them. Okay, so with an hypotenuse of under 100, but are they even organized? They're not organized. This one is 100 and that one is 89. I know there is like a tendency going up, but really, like, it's the smallest side is always the one here or something. What? But where's 345 here? This is bullshit. Okay, okay, okay. It starts over there. Wow. Yeah, I did not really prepare for this video at all, but okay, here you can see there's 5, and then here there's 6, 7, 8, 9, 10. Nope, nope, nope. 8, 7, okay. 8, 9, 10, 11, 12, 13, 14, 15. Damn. I missed one, didn't I? There's supposed to be 16. There's 5 right here. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. Okay. I don't know if you counted those with me, but I don't know why I even counted them. But yes, there's 16. And the way I made sure my script worked is I just looked at the amount of like whenever I changed my script a bit and I wanted to make sure it worked, I would just start it and then end it when it passed the hypotenuse equals 100, and then count the amount of triangles there were. And I knew that it worked if I counted 16 up to 100 without counting this one, 101. And about 2 days ago, I tried like figuring out if there were some numbers that would never appear, either as the hypotenuse, even, or odd side, and I couldn't really figure it out, but I can prove you that every multiple of 2 plus 1 is in there somewhere for the small side, no, for the odd side. So imagine you have a triangle which has a side equals to 3, a side equals to 4, and a side equals to 5. That's the 3, 4, 5 triangle, the most basic one. And now imagine you're looking for one that has a side of 5. That's there's no way that. Oh my god, I'm not explaining this properly. I'd have to think about this before explaining it. Oh my god. I lost my video making skills. Kappa, never had them. Um, hmm. How do I explain this? Um, is it even in order? I think it is. Let me just look at my thing for a second. I think that's how I figured out they were all there. It's because they're in order. 1 second. Don't print that. Play stop. 3, 5, 7, 9, 11, 13, 15. Yep. Okay, yeah. So basically, it's always gonna be. I should go on paint. You're always gonna get a triangle like this. Oh, that was actually really good. And this is gonna be n. Or actually, fuck off. Okay, you're always gonna have something like this. Wait, can't you use something to draw a triangle here? Ah, you can. Nah, mine's better, isn't it? Alright, why isn't this... Okay, there we go. So, you're always gonna have a 2n plus 1 thingy. So, imagine it's 3 and you're looking for the smallest example of n equals 1. So, 2 times 1 plus 1, 3. What you're going to find is 4 and 5. And then you can look for the smallest one that has a 5 here. And you're going to find something different. And you can keep going like this forever with every multiple of, with every n. And you're always going to find a new triangle that has no common factors with like each side. Um, That's a terrible, terrible explanation. It's not even an explanation. It's not even a proof. But it kind of when I thought about it the other day, it seemed very obvious. But that's not how I thought about it. I just realized how I thought about it. Okay, we're gonna have to open up Notepad. Basically, when you have these triangles, what you're looking for is something like x squared. Oops, x squared. Fuck me. X plus 1 squared minus x squared equals b. Let's say b is the odd side squared. Actually, a would be like the odd letter, right? So that would be um, 4n plus 1 squared minus 4k. Actually, let's just write 16k squared equals a squared. And there is always going to be a solution. If you look for a equals 1, that would be like phi. So it doesn't work. But if you look for a equals 3 and you try to solve x plus 1, I'm going to do it with you, wow, equals 3, you're going to find x squared plus 2x plus 1 minus x squared equals 3, 2x plus 1 equals 3, and there you go. And now you can say x equals 1, then you're going to find, what am I, 2x plus 1 equals 3. Did I mess up somewhere? I don't know if I'm... Yeah, okay, yeah, I did everything properly. It's because that's not really what I wanted to do. Um, but that's cool. So now we get 2 squared minus 1 equals 3. Yeah, that's why it doesn't work. That's why it doesn't work. I wanted to get an a squared equals 3 squared. This is what's wrong. There we go. 3 squared. And then you're going to find... So that equals 9. Actually, I guess I could do that, huh? And I can't come back. This is bullshit. X squared plus 2x plus 1 minus x squared equals 9. 2x plus 1 equals 9. X equals 4. 5 squared minus 4 squared equals 3 squared. And then you can say here equals n, here equals n. 2x plus 1 equals n. X equals n minus 1 divided by 2. And here you can have n n plus 1 squared. Mm, is that it? No. I mean n minus 1 divided by 2 plus 1 squared. Whew! This is weird. What am I doing right now? N minus 1 divided by 2. I swear this is not where I wanted to go when I started this. Holy, but this is interesting. Equals n squared. Does that even work? Let's try to expand this. Oh my, yeah, that would be a pain, huh? N squared over 4 um, plus 1 over 4. Oh, but there's a plus 1 in there. Wait, it would be, can I do that? No, I'm not gonna do it, but I think, this should be right. I don't think I made any mistake. 21 minutes! Probably gonna be the only one rewatching this eventually. But yeah, and then you can find every square number like this. Every square number, oh my god. You can find every odd n with this. And you can also find every multiple of 4 with this. If instead of doing x plus 1, you enter here x plus 2, and then you look for b, which would be the even side, you could find all the multiples of 4. And if you try to find a multiple of 2, actually, can I prove that? Wow, could I prove it? Could I prove it? X plus 2. Oh, x plus 2n. If I want to prove it, I have to do every possibility squared minus x squared equals 4k plus 2 squared. Yeah. Oh my. Um, that would be 4nx plus 4n squared equals 4. I proved it, didn't I? Because though, wait, that's gonna be 4. Yeah, bullshit, I can't prove it. Well, I don't know how to prove it. Too bad. I can tell you that's how it is, but I can't prove it. And I might be wrong saying so, but I mean, I only looked at 1,000 numbers, so sue me. Um, but if you use a script that only looks for multiples of 4, looks if they're multiples of 8 plus, I mean, okay, you use a script to find the hypotenuse as a multiple of 4 plus 1. If it's also a multiple of 8 plus 1, you want to look at multiples of 4 of 8 plus or minus 1 for the odd side, and if the hypotenuse is a multiple of 8 plus 5 for the odd side, you want to look at multiples of 8 plus 3 or plus 5. And then you just want to find the other side by doing like c squared minus a squared equals b squared. You look if b is an integer, and if it is, you look if you've already done that triangle, then you print it. And if I want to find the first, let's say 10,000, if I want to go up to hypotenuse equals 10,000, I'm going to do it right now. It's going to take me like a second, okay? H equals 1 to 2.5 thousand, start. It's going to take me, I would say, about another 10, 20 seconds. It's already on 5,000. Um, yeah, it's going really fast. Oh my. already on 7,000, and it's printing so many numbers. And this is the last thing I want to talk about. I'm gonna try to find an example near 10,000 when it's done. It's on 9,000 right now, 9.5 thousand, 9.7, 9.9, 10,000. Oh, okay, 10,001. You have 10,001, 200, 9,999, and 200. So this is like this is basically this, and then that would be 2 times wouldn't it be 4 times? Yeah, 4 times that plus 4 equals, so those are always cool. Um, and there's another one, which is, I'm just gonna type the numbers. And now I'm going to try to find one that has maybe 4 or 5, 1 second. If I can't find one, I'll just go to the example I wanted to talk about earlier. Well, earlier. Okay, yeah, okay. Um, 1 sec. And then finally 8424387. Alright, those are 4 different possibilities of numbers you can square and add up and get 9,265 squared. 4 of them for one number. And now you might think, what the hell? You can have numbers that have like 2 different possibilities, and you can find some really early. I think, isn't there one? I thought there was one like super early. I guess it's not that early, except maybe they don't show it. 1 second. I'm just gonna have to trust my script to show it to me. So for 65, yeah, it's because it doesn't show you the right. Okay, there we go. Nope, nope. 1 second. Okay, there we go. 65 right here. Um, 16, 63, 65, and then 33, 56, 65. So that's really cool. I mean, there's 2 different numbers, and that's the first example. This is the lowest number um, you can find 2 different possibilities for. But on 85, there's more. Um, so there's an 85 here. Let me try to find the other one. Right here. 13, 84, 85. 36, 77, 85. That's another one. And today I was just testing how good my script was, and I put higher numbers in my thing. And one insane example that I found is 196,185 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different possibilities of numbers you can score and add up and get there. And 196, oh wow, 1,960,049 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. Like, what the hell? Some numbers have 12 possibilities. I'm just going to try this on Wolfram Alpha actually and see what happens. A squared plus b squared equals 1 9, wait, no, was it? Yeah, 1961249 squared. Come on, give me solutions. Um, what? 108. Oh, it's because it's, oh, okay, yeah, yeah. I think you have to divide that by 4 because all of these give you a negative a, and all of these give you a negative b, and all of these give you a negative a and a negative b. So you only have these that are correct, you know? So that's only 1/4. But still, that'd be 27 integer solutions. What the fuck? A 108? How? What if I remove the positive? Maybe. Why does it keep giving me negative values? That's weird, but whatever. Um, 108. Wow. How the fuck does that happen? You know? Like, what? What? How do you get 108 integer solutions? Yep, that's gonna be it.